there. Yeah, I'm getting ready to start anyway, so that's there. The last chapter was relatively confusing in spots. You know, there was some tough, or last lecture, there's some tough materials. Hopefully, arrays is not that difficult for you. That they're, you know, they've been around for a long time, and we're actually going to see arrays in a lot more detail when we get into MATLAB, because MATLAB, that's the specialty is array processing. So, but we're going to go ahead and this is another long chapter, but I will probably cover most of it today simply because the material isn't as much drawn detail out there. So let me just jump in here and just start going here. Okay, we're talking about arrays. In arrays, you've already dealt with arrays in real life in other areas out there, but that's... Is that my computer? Okay, that there. Well, we're going to be using an array to represent lists, tables of values, that there. If you've dealt with Excel at all, Excel is an example of a table, that there. So we're going to look at how we initialize an array, look at individual elements, how we can pass arrays to functions, how we can use them to store lists that there. So, you know, an example of an array might be the high temperatures in Kuala Lumpur for the month of October. So that there. So every day you would record a temperature, and that's a list or a table right there. So we'll also finish up there where we look at multi-dimensional arrays, two-dimensional arrays that there. I won't get into variable length. You know, the last couple of topics I'm going to skip in this chapter right there. So, right there, this is just simply right there, the table contents right there. So, an array are data structures right there. And in chapter 10, which we won't get into, although I may jump in and talk a little bit about the beginning of what a structure is. If this was a course in just straight C, I would get into structures in a lot more detail. But as I said, we'll probably stop after chapter 8 so that I can jump into MATLAB that there. But structures are an important concept that there, so I may talk about that. But arrays and structures are static in the respect that they remain the same throughout the program execution. They don't change much out there. Once we define an array, it's a place of memory and it just stays there. We don't move it around. We don't that there. So an array is a continuous set of memory locations that have the same type. One way of looking at it is a condo complex. Each unit has got basically the same type. It's an apartment. It's a place where people live. And each one of those has a unit number. Now you can have a two-dimensional array, which would be like a condominium complex, where each floor would be, you know, have unit numbers. So you would have the floor number and the unit number. You could have a three-dimensional array where you have different blocks. So you can see where when you look at a condo complex, you can look at the same type of numbering that you see in arrays. So you could be, you could be block 1, third floor, unit 3. So your condo is 131 or whatever. I made up the number that there. But again, that's how we look at arrays. And arrays can be different. Each element of the array can be something different. It can be a string. It can be a name in the table string. It could be a temperature in the case of that there. If I wanted to store an array of temperatures for the whole year, I can subdivide that into a two-dimensional array where I have each month, 0 through 11, or an enumerated type, January through December, and then the day of the month. If I wanted to go with a three-dimensional, I could keep the temperature for each hour within the day. So I could define a temperature as, well, and I'm going to give it the U.S. form because I'm going to give month first. But I could go, 3 for the month of April. I can say 12 for the 12th of April, and I can say 22 for 10 o'clock at night. And I store in my three-dimensional array the temperature of that particular time. So here's an array, and I can't use a pen. I can use this here. That shows this is 12 units. Now C starts the array with 0. If you use some languages, they start the array at subscript 1. Visual Basic starts with subscript 1. Actually, it starts with subscript 0, but if you dimension an array of 12, it actually dimensions it to 13 elements. If you dimension the array of 12 in C, it dimensions it from 0 to 11. MATLAB, when we get into MATLAB, follows the C notation, so that's there. So, but what we've got there is when I talk about C8, that's the value of -3 right there. So this is a 12-element array. So the first element is the 0th element. An array name uses the same naming structure as any other variable right there. And then we put the index in a bracket. Now, one of the common mistakes is that people will use parentheses. And that gets relatively interesting because some languages use parentheses, some use brackets. C uses brackets. If you use parentheses, that's a function call. If you use brackets, that's an array element. So that there. So just kind of keep that in mind that when we see something that looks like this, that's a function call right there typically. If we see this, that's an array element right there. So that's how they keep it straight. Other languages just use, if something's declared as a subroutine or a function, it sees this, it treats it as a subroutine. It's declared as an array, and it sees this, it treats it as that there. So that's there. So we can have within that variable names within our braces. So what this is going to do is it's going to evaluate A plus B to determine what it is and then increment it by 2. So in this example, they say A is 11, 5, B is 6. So we're looking at the 11th element of the array, and we're going to say that C11 is equal to C11 plus 2, right there. So that there. So this adds 2. So this is the index array is called an L value. It can be used on the left side as an assignment. That there. Basically, we can initialize arrays by using for loops. We can use switch statements to increment various elements of the array, which we'll see later in the day, right there. So this just gets into a little bit more detail. Here, we're just doing a printing where we're going to take the C0 plus C1 and plus C2. Now, each one of these elements of the array is a value stored in memory, right there. So we can treat each one of those as a separate variable, just like that there. Now, this array, we have to assume, is an array of integers because of the values they stuck in there. So, but again, this is basically to divide the value of 7 by there. Again, they're just given more examples right there. So the braces, they're same level of precedence, that there any math operations within the braces follow the same rules as that there. So again, these are all the operators. The braces and parentheses fall on top, which is followed by the postfix, and right there. Prefix is That there, and you know, some people, I've actually seen people do something really silly. I don't know why they allow it, but I've actually seen people do this. Oh, I don't know what I've done here. Oh, I've closed. Well, never mind. Right there, I've seen people use prefix and postfix with the same, you know, with the same variable. It makes no sense, but I've seen people do it. It shouldn't work. Some compilers don't allow it that there. But all this is just basically saying that the braces are on the top. It's going to evaluate that before it does any other math within the equation. So if I use an array element in an equation, it's going to determine what element of the array is first. That there. And, you know, I've never seen that being an issue that there. So I'm going to just kind of not define an array. They occupy space in memory right there. You have to specify the type of elements in the array. If it's an array of integers, that's great. Now, if you define a structure, which we haven't done that there, let's say I define a structure that there, I can have an array of structures. I can have an array of long integers. I can have an array of real. I can have an array of strings. Now, a string itself is an array. Right there. It's actually an array of characters. Right there. So technically, if you have an array of strings, it's a two-dimensional array. Right there. Because then each character in the string is also an element. And we can treat those as arrays if we want to. Right there. So, again, there. And it reserves, this is the statement right here, int, ignore that period, that's just for highlight. But we define an array as int, the type, the name of the array, whatever name we want to have, right there, and the size of the array. Now the size of the array starts at 0 and goes to n minus 1. So this is 12. This defines it in the range of 0 to 11. Right. Here we're defining two arrays, b and x. They're both of type integer, right there. B goes from 0 to 99 elements in there. X goes from 0 to 26, right there. Arrays can contain other types, right there. So, like any other variable, uninitialized array elements contain garbage. So when you first initialize an array, it doesn't contain, you know, you don't know what the values are. It's just garbage. Whatever happens to be in that memory location is what's there. Just like if somebody gave you a condo in one of these buildings, you don't know what's in that condo. It's not going to be empty in some cases. It may be filled with junk. That there. I bought a house one time, and it wasn't a new house, it was an older house, but I went to the crawl space underneath the house, and I discovered that the builder that built all the houses in my neighborhood, that's where he threw all of his forms from when he was building the foundations. So I had all kinds of garbage underneath my house from when the builder built the houses down my street. The previous owner never bothered to clear it out. I hate to say it, I never bothered to clear it out. I just left it there. It was hidden away from view. So the guy that bought my house from me ended up with a bunch of garbage underneath the house. Right there. I mean, it was building materials. It wasn't garbage, but it was, you know, building materials. You know, actually, when I look back at it, a lot of those were made out of metal. I could have sold them for scrap metal, but that would involve the work of carrying them out of underneath the house. That there. But that there. So you can initialize the array to zeros right there, and right here. This is int 5. I've declared an array of 5 integers right there. And for size t, now notice this term size underscore ti right there. That is a special variable name which basically means the size of the array right here. Right there. So again, this just simply says that we're going to initialize that there. I don't use that size t, and I don't really worry about it there. I would just say int I equals 0 to, but it's a type that basically means the size of an array. But it's from 0 to I minus 5 to plus right there. The size of the array is defined right here, so it doesn't point to a particular array. Again, I don't use that type. It's just a weird type right there. So he talks about it right here, which is an unsigned integral type. So why not just use unsigned int or int, right? It's just one of those variable names that it's defined and you can use it. If you're going to write a book on C, you'll talk about it, but other than that, you'd never bother with it right there. But it's the same thing as unsigned int right there. So recommended for any variable that represents the size of an array. It's defined that there in standard definitions, which is included in standard I/O. Standard I/O includes standard definitions. Don't get hung up on it. Don't even worry about it. Just right there. Just use int I equals 0 that there. So it's right there. So again, we can also initialize the array when we declare it. Now we're using the braces. And so we're saying int 5, there's 5 variables in there. We're going to say n0 is 32 and 1 is 27. And we're declaring each of the 5 variables within the array at that point, right there. And that just simply shows it up there. And again, I'm kind of going relatively quick because here is probably a very efficient thing. This initializes the entire array to 0 right there. That's probably the easiest way when you declare an array, initialize it to 0 at the beginning, right there, to make sure they're empty. Right there. So explicitly that there, but it does the other, not all 10 of them there at the same time. Right there. Important to remember that arrays are not automatically initialized to 0. That's where this statement n bracket 10 close bracket equal brace 0 close brace. That statement will initialize the entire array to 0. So it's just a habit to get into right there. So it's important that remember you must initialize the first, and the remaining will automatically 0 right there. Array are initialized before programmed for static arrays and runtime for automatic arrays. And again, I'm not going to worry about that right there. And again, this will generate an error right there because I've got 6 variables and only 5 array elements right there. So you can't initialize elements that aren't defined. So I count 1, 2, 3, 4, 5, 6. This is n5. So what's going to be, what am I going to initialize at 14? There's no 6th element of the array. So that generates an error right there. Now, if you have fewer than that there, now this is getting into an interesting situation. This is where C gets the shorthand gets there. I say int and I leave nothing in the bracket, but I put 5 elements here. So that tells it it's going to be a 5-element array right there. So, that's kind of an interesting situation where the sign, it gets the size from the right side instead of inside the braces. Almost every other language will give you a syntax error if you try that. But C allows it right there. So that's there. And this gets into another here. Here we've defined a constant, and we haven't talked about constants before. When we define a constant, everywhere we see the word size, the compiler will replace it with the number 5. Now, it's important to keep in mind that size is not a variable. I can't change its value in the program. It's a constant right there. And it's that there. Constants are used by programmers typically with information that doesn't change in the program but might change later on. And we don't want to hard code it. So, for example, if I'm writing a software program where I'm printing out receipts for a customer and I want to calculate GST, I would probably use GST as 0.06. That's what it is, and it should never change in a cash register program. You know, the store owner can't change the value of GST to 7%. He can't change it to 5%. That's fixed by the government. But, you know, there may be an election coming up, and after the election, you know, the government might decide that 7 or 6% is not enough and it needs 8%. I'm not saying that they're going to do that. It's not a political statement. But, you know, they may say that 6% might be too much and we're going to lower it to 4%. You know, so either way, I mean, the government might decide that GST could be changed. Right there. Well, you know, since it's placed as a constant at the beginning of the program, it's easy for the company that makes the cash registers or software for, or I shouldn't say cash registers, but the computer program for tablets or whatever the store is using or restaurant's using, to update it because it's at the top of their code right there as a constant, and then just supply all their customers with an update. And of course, that's when, you know, if a customer is running an illegal version that's not registered with the company that wrote the software, well, I guess they're out of luck. They won't get the update. That's one way that pirate software vendors can, you know, users tend to get stifled. Although if they got the original program through a pirate channel, they'll probably get the update through the pirate channel too, right? You know, so not necessarily a great fix, but it, you know, at least puts a delay. But everywhere in this code, it sees the word size, it's going to replace it with the number 5. It's a constant. So here, j is less than size. So j is going to be 5. Here, s of j is equal to 2 plus 2 times j. So this is that they're, I'm using j, of course, as the element number. So this is going from 0 to 5, or 0 to 4, excuse me, right there. So I'm in volume value. Here I'm printing the value of j and the element right there. So here the key thing that we're doing here is we're looking at how we traverse through the array from the beginning to the end. We're using that with a for loop right there. And again, j can be defined as an int or an unsigned int, or we can define it whatever we want right there. It is a block level variable at this point. We talked about that last time in terms of scope right there. And we're saying s of j is equal to 2 plus 2 times j. Right? But we're using j both as the element number pointer and a value in calculating what goes into that thing. And this just does the calculations right there. And after I'm just going to keep going. So this is a preprocessor that there. And again, this just points out that the symbolic constant is replacement text by the C. So before it compiles, it goes through and takes out the word size and puts the number 5 in. So it's not done every time you run the program, and that there. When the program is compiled and stored in as an executable file or whatever it is in Android or Apple OS, you know, whatever operating system works, the executable file will actually have the number 5 in it. It won't have the word size. Right? So, and this just goes through all kinds of, right there. And this just explains the same thing. I should point out that there is an error. is that we normally use, when we're using constants, we normally use all uppercase so that we know that it's a constant and not a variable name right there. That's just a habit you get into right there. Multi-word, separate the words with underscores. Right there. This is another example of a program. Here we declared size, an array of 12 right there. We initialized it with 12 values. We said total is equal. And here we're just going through and we're adding up all the values in total. Right there. Just another example right there. Nothing new in this example right there. Here, this is one that, where am I at? Oh, we got plenty of time right there. Here we've got an array called responses. We got 40 responses to find here. I don't know what that is. It's not called for birds. Up there. We got 40 values in here. And here we're going through here and we're looking at, these are values from 1 to 11 right there. Yeah, this is the size is 12, so is that there? And we're looking to see how many ones there are, twos there are right there. So we're incrementing, again, we're using the name of the array, frequency, and responses, we're using responses is this array here. And we're looking at what that value is right there, answer. And this is going from 0 to 40, or 39, excuse me. And so we're traversing through the array right here, which is our responses array. So what we've got here, and it's easier if I can use my pen here. We've got this array here called responses, and right there. And we got the 0 element to the 39th element right here. And each element in here is going to contain a 1, 3, 6, 10, 4, 2, 1. So, a number between 0 and 11 right there. We're going to go through and we're going to start with this one here, and that's a 1. So I've got another array here called frequency. And I'm just going to say FREQ for frequency right there. And it goes from 0 to 11 right there. So if this is the number 1, I'm going to increment this element right here. If this is number 3, I'm going to 0, 1, 2, 3. We're going to increment this number right here. So that's what this particular program is doing right there. And of course, the next few slides probably explains this in text, but graphically, it's kind of easy. It's easy to see what we're doing right here. So at the end of the day, it's going to print out, and I've got 11 number 6s in here. Actually, frequency goes from 0 to 10, excuse me, not 0 to 11. I missed the fact that it's 11, not 12. I'm used to seeing 12 right there. But if I counted, the number 6 here pops up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times right there. So that's what this particular program does right there. So if we were running a little short, I'd probably stop here and have you do this, but I'm going to keep going here. But this is kind of an interesting program because here we have 2 arrays, frequency and response. We're traversing through the larger of the 2 arrays, and we're incrementing values in the smaller array based on the values that are in the bigger array, larger arrays. Right there. So again, this is used to summarize the value of people. In this case, I didn't read this earlier, but 40 students were asked to rate the quality of food in the canteen. So they rated between 0 and 10, and this is the result of the rating. 2 people thought that the food sucked. 3 people thought it was absolutely great. It was up to a 5-star restaurant quality. But 11 people just gave a slightly better than average. We'll assume that 5 is just, it's okay right there. So, but again, this is a way of looking at the data. So we ignore 0 because they have one logical response, 1 increment. So it goes from 0 to 10. So the for loop explains, this just goes through the code again. This is one of the reasons I can go through 50 slides in 40 minutes, because I skip the explanation, but I go off to one of the things that they talk about is when you look through the array, you should always have some kind of check to make sure you don't go beyond the value of the array that will generate a runtime error. Right there. And this is referring to an element out of bounds right there. And you can read these there. This is a program that I wrote one of my very first computer programming classes. We had to go through and graph elements with a histogram. And what this basically does is it just goes through here, and I can take the same data, or this is using 5 data that there, and we're just building a short little graph. Not exactly very impressive, with Excel and MATLAB, you can do graphs much quicker than this, but this was back in the days of Fortran and no graphical monitors. This is how we would do graphs right there. And what we're doing here is we're printing between J and the value of N, which is 19, 3, 15, 7, and 11 from our initialization. And we're printing that little asterisk that many times right there. And then we end the graph with a new line. Now this does a printf. We can also just do a print chart, print printf with a \n. That's there. The print string with the empty string does the same thing right there. So, and what that prints is something that looks like that right there. Not very impressive by today's standards. There's a lot better ways of doing that, but this is the early way of doing the old green bar paper tables and graphs. I think I remember as a college freshman having to do a sine wave using this technique. This is one where we roll a single dice 60 million times and check to see the random number. Same thing here is that I've got an array of frequency initialized to 0. I seed my random number generator. We talked about that before, right there. I roll my dice 60 million times, right there. So, right there. We say that the value of our face is equal to 1 plus the random number, that there, %6. So that gives me a value between 0 and 6, or 5, 0 and 5. And I increment that frequency, right there. So I'm calculating what the dice is thrown as and replaces the entire switch. Earlier we looked at the same program with a switch statement. Now we're using the array to store the frequency. And we get something similar to what we looked at before. Right. Similar type of data right there. So we roll our dice 60 million times, And if it was a purely random number generator, we would get close to 10 million on each, and we've got fairly close to 10 million on each. So our random number generator has given us a fairly random data right there. Again, character arrays are, strings are character arrays. Char is a type between 0 and 255, right? And the type of data stored in a string is an array of characters. Now we can define them as a string, and C will automatically define that for us as an array of characters, or we can define it as an array of characters ourselves right there. So, right there. Now again, this is looking at the fact that when I say open quote and close quote, this is going to define the size of string right there, and it's going to add one more for the null character, which is an end of string flag, which is actually the value of 0 right there. So string contains 5 characters plus a string termination called the null right there. So it actually contains 6 characters. The constant representing null character is \0 right there. So that's how you would look at it. And if you use the capital word null, that also means the same thing. That's it. Now also note that the single quotes define a single character. Double quotes define a string right there. So the array character should be large enough to contain the number in the string and the null right there. So again, we can go through and we could find our string this way. That does the same thing. And notice first character, second character. We're going to have 5 letters here and then the null character at the end. Or we could use char string 1 equals quote first right there. So this just kind of goes through right there. Now again, we've got the scanf where we use the %s that will automatically right there. Here we declared a string of length 20 right there. Here we defined, and this is kind of an important thing right here, I define my string as 20 characters right there. Remember, I need 1 space for the end of the null character right there. So, and because I define it explicitly as 20 characters right there, that null character is not automatically added like it did with the first. Because first counted the number of letters and then added 1 more for the null character. When I say string 2 bracket 20 close bracket, that means I'm going to define a string with 20 spaces. So the largest string that I can read into it is 19 letters. And that's why here I'm saying scanf %19s. So I'm going to read in a string of up to 19 characters. The reason I put the 19 in there is that if I type 23 characters, there's no place for the other 4 to go. My string is only 20 characters long and I need a place for the null character. So I define the size of the string. Everything beyond 19 is just thrown away. Right there. So, right there. So again, in 6 there, functions that there. Now, when we pass an array to a, I'm going to finish this topic here. When we pass an array to a function, we don't pass the data. Now remember before when we talked about when we call a function, and it doesn't like my finger. Oh, I crashed it again, didn't I? My OneNote keeps crashing on me. I don't know what I'm doing wrong here. Okay. Before, if I said square, and I pass it 5, or let's not pass it 5. Right there. And actually, we'll say y is equal to square x. And we're going to say x is equal to 5 right there. In my function int square, int, and I'm going to say z, just simply to right there, return z times c right there. Here's my function right here. When I called this before, I took x and I made a copy of that and put that in 5 right there. I made a copy of x. I didn't pass the address of x. So if in my function I said c is equal to 6, I didn't change that in my main program right there. In this particular case, this would return, instead of 25, it would return 36 because I changed the value of z to 6. Or if I did plus z right there. Now, if I incremented z and then I calculate the square, which would be an error, it's not going to give me the square, it's going to be the square of n plus 1. But I made a copy of that there. I pass its value, not its address. I can't change x in the main program. That there. And if you remember, when you call the function scanf, right there, you passed it. We're going to see x is declared as an integer. We passed it with the ampersand, the address of x, because scanf needs to change the value of x. Because I'm going to read that from the keyboard. We pass its address. When we're dealing with arrays, we're always passing the address of the first element in the array. That there. Now and this gets a little bit confusing. That's why I'm going to kind of end on this note here. If we pass a single element in the array, then we're going to pass the value. But if we pass the entire array, then we're going to be passing the address of the first element. And then we can increment that. And not only do we normally do that, we also pass it the size of the array. That's there. So actually, we don't have to pass the size of the array unless it's a 2-dimensional. Then we have to pass the size of the second. But we have to pass it at there. So when we deal with a function, well, we have to, in our function, we have to tell it that it's receiving an array. And usually we just do that by putting empty brackets right there. So scanf doesn't check how large the array is, but when we did the %19s, that forced it to check the size of the data right there. So again, here our printf, we're passing it the array of string 2 that there, but it's going to print. You know, the printf doesn't check that there, but it knows that when I did the scanf, I gave the 19. The 20th element in the array is going to be equal to the null character right there. So this, what I'm looking for right here is here again, printf at there, the string between, you know, this doesn't really get into too much. Here we've got 2 strings right at there, and this is at there. So it gets relatively confusing. Let me just kind of give another example that they don't talk about, which is probably more important. I'm going to have a function that's going to be a type int right there, and I'm going to call it read data. And I'm going to pass in an array of, and I'm just going to call it D, and I'm going to put a bracket right here. Right there. And what this is telling us is that D is an array. We're receiving that. So I'm just going to go ahead here and say int K scanf right there, percent I K, and actually before that I need a print statement. I'm just going to put it underneath here, printf, enter number of data points, number of points, right there. Right there. And the person's going to enter how many points there, and we can do for int j equals 0, j less than k, j plus plus, right there. And we can then do scanf. And what do we call this? Now I'm going to call it %D. And we're going to send it the address of D bracket J. Right there. Semicolon. Right there. Close bracket, return 0. Right there. Okay. Pardon the handwriting. But what I've done here is that I've declared an array D here, that I'm going to receive in an array, and that there. And the way I know it's an array is because I put this %, these empty braces there. So it's going to receive an array. We don't know how big the array is. Right there. So it's within our code to figure that out there. But we're going to go through and we're going to scan in each element of the array separately, because I'm sending a single element right here. This is a single element of the array. I have to put the ampersand in. If I was passing the array and I could call this in my main right there, and pardon that there, I would call x is equal to read date. What did I call this? Read data. Data right there. And I'm going to pass the array right there. Right there. And this is declared somewhere up here as int D array 20, for example. So I've declared an array of 20 right there. And that's an array of integers that there. And when I call the function read data, I don't have to tell it that it's an array or a address. Because it's declared as an array, the compiler automatically will pass the address. In my function, I have to tell it that it's received in an array, and the way I do that with the empty braces there. I don't have to tell it how big the array is. All that's telling the function is that it's receiving an address. So I can treat D as an array within my function right there. Now also notice that I don't return back anything in D. I change in the array the data itself because I'm receiving its address. So as I go through and traverse between 0 and, I'm going to just simply assume that's less than 20 right there. But I'm going to go between 0 and K, and I'm going to read the data from the keyboard, and I'm going to place it in the array. And the way I know I'm placing it in the array is that I'm passing in the scanf the address of the individual element of that array. Right there. So this gets a little bit confusing, and makes a little bit more sense when we get into chapter 7. When we talk about passing by reference and passing by value right there. But when we're dealing with arrays, we're always passing by reference. We're always passing the address right there. If we're talking about individual elements in the array, we're passing it the value unless we put the ampersand in front, right there. So it's a little bit confusing again, and I like to end classes on a confusing note right there. But when we're dealing with an arrays, right there, is that and arrays are static, so they remain there for the duration of the program. That's there. So that's there. But again, it's static local arrays. I won't get into that. That's getting a little bit more detailed. But yeah, I'm not going to get into that. Skip that there. So arrays to functions is what we just talked about right there. So here, for example, we're taking hourly temperatures, modify the array, and here we're passing the constant hours a day, which we assume to be 24. That's defined as a constant. And we declare an array called hourly temperatures. We're passing it, we're making it 24 elements wide. We're going to modify the array, and we're going to pass it hourly temperatures without the ampersand. Without the ampersand, right there. And again, it's automatically that there. So when we go through our function that there, and they don't really give show the example in code, but we're passing it the array hourly temperatures without the ampersand. It's automatically stuck the ampersand in there for us right there. So we can write a function just like I did with read data right there. And I think I'm going to, well, it's right about time for call for prayers anyway. As I mentioned, I'm good for an hour, and that's about what my back says. Lets me sit in this chair, actually, to be honest with you. 52 minutes, all right.